We have been familiar with the Greek letter pi since our childhood, but what makes it special is when you realize pi contains more digits than the total number of atoms in the observable universe. But how pi got its value? To understand it, let's take a circle and roll it once. Now, let's measure the distance traveled by the circle, that is, its circumference. Now divide the circumference by its diameter. That's the number we call pi. If you repeat the same process once again, you may get a little different answer because of the error in the measuring instrument, or maybe due to the variation in the scale less than a millimeter. It won't affect much while you are building something small because the error can be neglected in such a small scale. But what about when you are measuring something big, like the circumference of a circular orbit? The error may also scale up and cause some serious issues. So how to calculate pi with more precision? Let's say we have a circle of a diameter of 1 meter. Now place a square whose sides are touching the circle, and place a smaller square whose vertices are touching the circle. That is, the length of the diagonal is 1 meter. Now, to measure the perimeter of the bigger square, we have to add the length of all the sides of the square, and we get 4 meter. Now to get the upper limit of the pi, we have to divide the perimeter by the diameter of the circle. Since it's 1 meter, we get the same value, that is 4 meter. And to the perimeter of the smaller square, since we don't know the length of its sides, we have to use trigonometry to find the length of its sides. And by adding the length of its all the sides, we get 2.82 meter. And to get the lower limit of the pi, we have to divide the perimeter by the circle's diameter, and we again get the same answer, that is 2.82 meter. So now we know that the value of pi lies somewhere between 2.82 and 4. You may say that this is an even worse value than what we got in the previous method. But hold on, we can narrow this limit by doing the same process with a polygon with more sides. To get precise value, you have to increase the sides of the polygon to devastating values. And one more thing, just to give you an idea about how hard it is to calculate pi using this method. A mathematician spent nearly 25 years calculating pi using a 4 quadrillion sided polygon only to get the first 35 correct digits of pi. And this was the only method known for calculating pi until Sir Isaac Newton introduced a new method. That is, since the formula for the area of circle is pi r squared and the equation of circle is this, and solving for y and taking the radius as 1, we get a binomial equation. But no one at that time applied binomial expansion for the equation of circle except Newton. Now by expanding it, we get the binomial equation for the circle, and by integrating it, we get the area under the circle. Now that's the value of pi. To get a more precise value, you have to solve more terms of the equation. And just to show how efficient this method is, to get the same value of 4 quadrillion sided polygon from the previous method, you just have to calculate 50 terms in Newton's method. And one more thing, pi is an irrational number. That is, you can only get closer to the real value but never get the exact value. That makes pi contain infinite number of digits. But atoms in the observable universe is finite. So that makes pi contain more digits than the atoms in the observable universe. And as always, thanks for watching.